Hello and welcome to Folium. Today we're in a room that I can actually pronounce the name of, which is helpful. And we have the lovely blue light down here, so we're all feeling fresh and awake. It's maybe slightly sleepier upstairs. And we've got a great lineup for you today, including lightning talks after lunch to look forward to, so that'll be fun, wake us all up. I want to remind you all about the app. I don't know if you've downloaded it yet, the Front-End Conference app that you can get from the Apple App Store or the Google Play Store. You've got the schedule in there and other information, and you can also rate and review the speakers. And you can even rate and review the introduction and goodbye. So nice ratings, please. The ratings, you can see the stars on the different talks, but any reviews you leave don't get posted, so you can let the organisers know what you thought of the talks, and it helps them to make a good lineup for you next year, see what you like and what you don't like. So without further ado, I want to introduce to you Harry Roberts. When you hear about Harry, his reputation usually precedes him. He's CSS wizardry, after all. He's gone from working at BSkyB, already an enormous company, to working with enormous names that you've heard of from all over the world, really. He's your guy if you want to know about CSS. When I first saw Harry speak, he very quickly brought me around to object-oriented CSS, and I have to say my style sheets have never been the same. So today Harry's going to talk to you about refactoring, and even in a tiny organization like mine, with 2 people working on the front end, CSS can become such a nightmare and such a mess straight away, let alone coming to more legacy CSS. So it's really good that we've got Harry here today to tell us all about refactoring our CSS without losing our minds.
Well, thank you so much. Thank you. All right. Well, did everyone enjoy the party last night? Hangovers? No, like 3 people. What were the rest of you doing? I was going to say, because a hangover is the worst thing to have when we're starting the day with refactoring CSS, so I apologize for the timing. It's a fairly big talk. There's 83 slides, not as big as Vitali's, don't worry. So I'll need to keep up the pace. Refactoring CSS without losing your mind. We're basically going to start looking at some fairly philosophical approaches to refactoring, proving the business case for refactoring, also proving the business case for not refactoring. So we'll look at some fairly philosophical things, then we're going to move on to some pretty immediately applicable tips, tricks, and things just to make refactoring a little simpler. Anybody who has refactored CSS before knows that it's not particularly enjoyable. Quick hello from me then. I'm a consultant front-end architect. I basically travel around and help clients with their CSS architecture, front-end performance, design process, those kind of things. And I tend to do that at scale. A lot of my clients tend to be quite large, so this means that we've got big teams, so we've got a lot of people pulling in different directions, different skill sets. We've got just bigger code bases. We've got much bigger products that we're working on. And we've also just got longer running products and projects. So the amount of legacy is just much, much higher than you might find anywhere smaller. So as you can imagine, I end up doing quite a lot of refactoring work in my day job. And unfortunately, I really dislike refactoring CSS. It's a disgusting, horrible job. Quick show of hands, who has refactored some CSS before? Yeah, pretty much all of us. Keep your hands up if you enjoyed that process. One person, I do not trust you. Refactoring CSS, it's fun once it's finished. It's fun once you've got kind of, oh, right, it's done. We've got everything really nice and neat and tidy. But in the meantime, it's a really difficult job. We don't have really good test suites for CSS. We can't really spot regressions very easily. Everything's so deeply interconnected that we might be refactoring one part of the project and simultaneously breaking something on a complete different page. So hopefully in this talk, we will find some ways of making this simpler, find some ways of making it a little easier, a smoother process, and a process that is easier to keep track of. I'm going to start with a definition. What do we talk about when we talk about refactoring? There's a really nice definition from a man called Martin Fowler. Martin Fowler's a real clever dude. I read pretty much everything he writes. He's a very sort of computer science kind of developer, so a lot of it just goes straight over my head. But this particular definition, refactoring is the process of changing a software system in a way, in such a way that it does not alter the external behavior of the code, yet improves the internal structure. A really nice definition there, which immediately tells me that this isn't for our users. This is a business decision. This is a decision that the team would make to make maintenance quicker, cheaper, simpler. However, I would argue that ultimately, eventually, our users do see a benefit. There is an actual kind of user and customer-facing benefit to refactoring. If we're tidying up our code base, if we're keeping it nice and clean, it's going to be more consistent, it's going to be more stable, fewer bugs. It also means we can probably provide features or build features much more quickly so we can get things to the customer sooner. To my mind, and certainly for the purposes of this talk, there are three main kinds of refactoring. And the first kind is kind of as-you-go refactoring. This might be when you're doing a proof of concept for a new feature, and you just kind of hard code it and like throw it together really quickly just to see if it's going to work. But of course, we don't kind of commit that into master. We don't actually put that live. What we do is we take an hour to tidy everything up, perhaps dry it out, start using variables from the wider project. This is the kind of stuff we should be doing all the time. And if we don't keep on top of this, we can step into the next type of refactoring, which is technical debt. We'll look at technical debt in a little more detail in a few slides' time, because I feel it's often quite misunderstood. Technical debt is a strategic decision, right? It's not necessarily a bad thing. It's a strategic decision. Technical debt is when we do something right now, taking a shortcut, or right now with limited sort of knowledge or information, with the awareness that we have to go back and tidy it up later. So technical debt is basically we built what we could in the time that we had, but we need to set aside some time in the future to go and tidy things up. So technical debt shouldn't be feared as long as we're keeping up repayments. But this is a slightly more expensive kind of refactoring. And the third and final kind of refactoring is the rewrite and overhaul. And this is where you haven't kept up your repayments on your technical debt. The code base has got so nasty and hard to work with that it's actually going to be more effective to tear it all down and start again. And this is the most costly, most expensive type of refactoring. This is the kind of refactoring that we really want to try and avoid. Typically speaking, we find that as we go through the project, as the project gets older, the type of refactoring and the cost and scale of it increases. As you go refactoring, kind of tidying up as we're building things, might cost us minutes to hours, right? That's the kind of scales we're looking at. If we stray into technical debt, we might be looking at hours to days. We might take a few days to tidy up a feature that we hacked together in order to meet a deadline. And then finally, rewrites and overhauls. These are the most expensive because these we're talking weeks to months. They're not only expensive because we have to spend weeks to months doing them, we need to fund that, but also it's an opportunity cost. The weeks to months of rewriting is time that we can't spend adding new features, so there's a huge opportunity cost involved. So what we need to do is we need to try and capture everything before it gets to this point. This talk's going to talk mainly about the latter two types of refactoring and kind of the overlap between them. How can we treat technical debt in such a way that it doesn't lead to a rewrite? How can we capture things in that kind of transitional phase? Okay, technical debt. Honest show of hands, who hasn't heard the phrase technical debt? Okay, a couple of us. Technical debt is basically a debt like any other. It's a really, really fitting analogy. I'm just going to be really boring and read straight from a slide for this one. A debt means that you acquired something right now in exchange for a long-term financial burden. This burden isn't just about repaying what you got, there is also interest involved. This means that even if you pay back your debt timely, you will pay more than you took. And if you don't keep up your repayments, your debt will keep increasing. If you ignore the debt for long enough, you will eventually go bankrupt. The debt becomes unpayable. As far as technical debt is concerned, the URL at the bottom of this slide is it links to a fantastic article all about technical debt from a very kind of, just a very experienced perspective. The technical debt is a debt like any other. It's a choice to get something right now for immediate gain, but knowing that it will cost us a little bit more in the long term. Probably the most succinct example I can think of technical debt would be just using an important, right? It costs 3 seconds to put an important into a style sheet, but it might cost you 3 weeks to refactor it back out in a month's time. Technical debt there is that strategic decision to use that important. It is the decision to cheat now, to take a shortcut right now in order to deliver, but in the knowledge that we will pay more when we refactor it later. However, technical debt isn't something we should be afraid of. It's going to happen. It's a strategic and measured business decision, right? Getting into technical debt is fine. It's just vital that we keep up repayments. And one of the things that I find most people forget is that these repayments do incur interest. The longer you avoid refactoring your technical debt, the more it will cost in the future. So this is the interest that accrues on those quick win business decisions. So it's really important to schedule in bug fixing into every sprint or every phase of work. You need to provide a business case to your product owner or your project manager so that they understand the importance for us as developers to keep things running smoothly. Technical debt often gets ignored. Businesses very rarely will give you like a sprint to tidy things up. If you work in an organization where you do get that time, I would count you as very, very lucky. So talking about business cases then, when should we refactor things and what should those things be? Kind of the lazy answer to this is that we should always be refactoring something, right? There's always something we could tidy up or refresh or modernize. But a more sort of detailed answer, a lot of refactoring boils down to projections and estimates. If the projected cost of maintaining a feature in its current form is higher than the cost of refactoring or rewriting it, then perhaps we should begin rewriting it. If it's going to cost us more time to maintain a bad version of a product or a feature, we should spend the time to tidy it up so we get the benefits in the long run. We should only refactor if the current implementation of something is actually slowing us down. If it's causing us problems and sort of ultimately costing us money, that's another time that we should begin refactoring things. And from the opposite side of the argument, if we've got a proposed new version of something that provides real tangible benefit or tangible advantages over the existing version, that's another good reason to refactor. If we can prove, or at least sort of project, that a new version of something will save us time and money, that's a good business case for doing it. It's all well and good wording it like this, but let's look at some actual numbers. This is kind of a completely invented scenario, but it does kind of help prove the point. Let's say we've got 2 possible versions of a code base. We've got the existing code right now, which isn't particularly nice, or we've got the refactored version, which we don't have yet, but we could do. And let's say that somebody asks us to add a feature, and let's say that feature is a theme. So a customer asks you, we really like this platform, but we need to theme it so it looks like our branding. Now, the cost of hacking a theme into the site now might be 2 days. You might go to your product owner and say, I can hack one in 2 days, but it still will be a hack, right? Because the next time a customer asks, it will still take 2 days to hack it in, and then the interest accrues, and then it's going to take 2.5 days for the next customer because things get worse and worse and worse. So the ultimate cost of providing these features in the existing code base might be a total of 9 days. And this is where you have to be good at your estimates because you need to go to the business and say, well, actually, if we refactor the CSS so that theming is a first-class citizen, that'll take us 7 days right now. If we refactor it and add the feature right now, it might be 7 days. But if another customer comes to us and asks for a theme, it might take a quarter of a day because it's a first-class citizen now. We've built it into the framework as a feature. And subsequent costs may just be a quarter of a day each. So ultimately, refactoring now ends up cheaper. So this is the kind of thing you would typically take to the business as a kind of a case for refactoring. But unfortunately, and I know how much developers hate estimates, you have to be very good at them. You have to be able to stick to these numbers and make sure that you are kind of at least in the right ballpark. Because in the immediate case, refactoring is a lot more expensive. So you have to project the costs and take those confidently to the business. The refactor, so we talked about technical debt, but the refactoring column here actually presents the opposite. It shows us technical investment. So we can make a technical investment so that things get cheaper in the long run. This is potentially a gamble, though. You have to make sure that, or you have to be kind of confident that someone will ask for another theme. If one client asks for a theme and no one else ever does, you just spent 7 days on it once, right? And that is ultimately more expensive. But technical investment is the opposite of technical debt. Okay, I often think there is a good argument to be had for not refactoring things. There is a good argument for leaving things alone. This slide out of context just reads like really bad advice. So I'll go through some examples in a second. If you're not actually being slowed down or affected by something, there's no need to refactor it. If it isn't costing you time, don't spend time fixing it, right? It might be ugly, it might be a bit out of date or whatever, but if it's not actually costing us time and money, there is very little business case for actually going to refactor that. This next bullet point is probably the worst on this slide. If you can just ignore it, right? If you can just pretend it isn't happening, then probably do that. We've got a really good example of that. Don't just take that line from this talk. If it's something that can be captured by a rewrite later on, this happens quite a lot. I work with clients who, they will say, right, we're going to be completely rebuilding the platform next year, but in the meantime, we'd just like to refactor and tidy some things up. And I often just say, well, just wait until next year to do it all properly. Don't spend time in the next sort of 6 to 9 months fixing something that you're going to rewrite next year anyway. So if you can capture it with a rewrite later on, try and leave it alone for as long as you can. And yeah, finally, if a rewrite is the better solution, I'm sure we've all been in that situation where we've adopted a legacy project and we've tried to tidy it up and we just think, this would be a lot quicker if I just wrote it again. So if a rewrite is the quicker option, which sometimes it can be, perhaps try and avoid the temptation to refactor. So some examples. I had a client get in touch once who had a list of things they wanted to achieve, and one of them was, we want to rewrite all of our CSS onto the BEM naming convention. Anybody who knows me knows that I really like BEM. I don't think taking 2 weeks out of product work is actually going to pay itself back. You know, taking 2 weeks out of product work to change your naming convention probably isn't going to be worth it on its own. So I actually talked this client out of that. There are other problems with doing things like changing your naming convention. It has a large surface area. It affects a lot of the project, and that in itself can be risky. We'll look at that soon. You have to weigh up if it's actually worth it. In this case, it turned out it wasn't. It was just adopting a naming convention. I honestly, as much as I love naming conventions and BEM and the kind of transparency they give you, spending 2 weeks implementing it and doing nothing else is probably not going to be worth it. If you can prove that it would be worth it, if you can actually prove that, well, if all of our developers understand the code base perfectly, it'll be worth 2 weeks within the next 6 months, then go for it, but you have to follow the numbers. Another specific example, a client said, we think the code for the nav is really ugly, so we'd like to refactor that. And I took a look at the code for the nav, and it was really ugly. But I just presented the client with a few questions, because it felt like they wanted to refactor this purely out of a sense of pride, just because it looked ugly. Is it causing real problems right now? What's the problem with the nav? And it turned out the nav was completely fully accessible. It was working on every device and browser it needed to. The nav worked. It wasn't actually causing them any problems. Why spend money fixing something that isn't actually problematic? Then I asked them, how often do you have to actually go into this nav and make any kind of changes? And it turns out that if a user just adds a new page in the CMS, the nav gets a new item, and it had very little manual overhead in maintaining it. So it wasn't actually being worked on by anyone. We ultimately decided just to leave it alone. If it's currently accessible, works everywhere, works on every sort of screen size, fully responsive, and no one has to modify it manually, is it really worth spending 2 days refactoring it? And ultimately, we save time and money there by just leaving this thing alone. When the nav becomes a problem, when it stops working on certain browsers, when we have to manually work with it and it's really cumbersome, then we refactor. There's a business case in not doing so, because refactoring comes at a cost. Right, let's move on to some slightly more practical things then. A term that I came up with earlier this year, I think, is a refactoring tunnel. It's kind of a metaphor which it describes or sort of compares the amount of work you're doing to kind of a length of a tunnel. A refactoring tunnel represents a feature or a part of the project that you want to refactor or rewrite, and the length of that tunnel implies that it's going to be quite a long job. The analogy kind of works like this. Day one, you step into a tunnel, and you can see the entrance behind you, you can see the light behind you, but you can't see the exit, right? It's somewhere around the corner. So you step into the tunnel, and day two, you can still see the exit behind you, the entrance behind you, but you can't yet see the light at the end of the tunnel. And after about 10 days, you're right in the middle of this tunnel somewhere, and you can't see the entrance, and you can't see the light at the end, and you've got no idea how far there is left to go. This happens all the time when we're refactoring. We pick off too much. We pick a feature or a part of the project that has a very large surface area. We try and refactor it all. We end up in this long tunnel. We ultimately end up lost. We don't know if we keep going for one more day, are we going to get to the end? Or is it going to be 10 more days? We don't know anything. This happens really frequently. It's happened to me a lot of times. It happens to my clients all the time. We need to pick off much smaller bits of work where we can always see the beginning of the task and the end of the task. Getting lost in the middle of a long refactoring tunnel often ends up with, the nav's broken. I tried to refactor the naming convention at the same time, so actually the footer on this page doesn't work. For some reason, the responsive grid stopped working. And then after about 5 days, we just do this, right? Who's been there before? Everyone's been there before, right? This happens all the time. When we've just spent 5 days trying to refactor something, and we realize that, shit, I'm lost, and everything's broken, and we just start again, and we just lost 5 days of time and money because we tried to pick off more than we could chew. So we need to avoid these long refactoring tunnels. A long refactoring tunnel is anything that basically goes through your entire project. A really good example would be a naming convention. Refactoring your naming convention has a huge surface area. It affects every single bit of the project. We should avoid refactoring anything like this. Porting your entire code base from SAS to CSS Next, for example, or post-CSS, it has a huge surface area. This is a long refactoring tunnel. We will spend a lot of time with the code base being in a mess, and it will take a very long time to actually work out how much we need to, or how much we've got left to do. We also get really specific problems. If we're going to refactor something that goes through the entire project, there are going to be huge deltas to merge in. The chance of merge conflicts are going to be huge. The bigger the surface area of the refactor, the bigger the surface area of the merge. Also, it's really easy to inadvertently introduce regressions and new bugs, right? If you're trying to refactor your entire project, the chance of adding in new bugs is much, much higher. So instead, what we need to do is find things with a limited and clear scope. Don't take on big refactoring projects. Pick small, limited scope features, refactor those in isolation, and kind of rinse and repeat. An example would be, instead of refactoring your entire site onto the BEM naming convention, perhaps just completely refactor just the nav. The nav is a limited scope, it's a clear scope. You know when it's finished. It's going to take you a day or two to complete. You can refactor the nav onto BEM and port that back in. And if you keep on doing this, the site eventually refactors itself. By tackling these small bits in sort of manageable chunks, the site ultimately refactors itself. These short tunnels that we are now picking off, we need to refactor these in isolation. This is a really important point about refactoring. We should never rebuild or refactor features back into existing or stale code because you're basically going to be relying on CSS that is already out of date. If you're going to rebuild a feature, particularly in CSS, we should take it out of the project, put it somewhere completely sandboxed, and ensure that we're building it completely from fresh. Make sure we're not leaning on any legacy. Because of the way CSS works, everything sort of cascades and inherits. If we rebuild a feature directly into the project, there is every chance that we will end up recycling some legacy CSS that itself will be refactored out of the project in 6 months' time. So fire open JSFiddle or CodePen or whatever it is you use, refactor the feature there, then port it back in. Once we port it back in, then we do any tidy-up work. For example, let's say we work for The Guardian and we decide today we're going to refactor the header. We drag that out into JSFiddle, and here we can use new naming conventions. We could perhaps start using flexbox instead of floats. We could perhaps swap out the icons from PNGs to SVGs. This is our chance to do exactly what we want to do and do it correctly. This is a chance to kind of forget any legacy or any previous CSS and start from scratch. Then we just copy and paste this back into our existing project, right? But of course, if we just copy and paste a new CSS back into an existing project, it's fairly safe to assume there are going to be some conflicts, and collisions and breakages and regressions. Which brings me on to my next tip. All initial. Who's heard of all initial? Oh, not many people. Right, so all initial is really, really useful when you're refactoring. All initial effectively stops inheritance. All initial sets all of an element's properties back to their initial value. It effectively stops any legacy or anything at all. Not even legacy, it stops anything leaking into your new work. And it's a very progressive way of defending against legacy. It's a progressive way of defending against leakages or style collisions. Keen to stress the word progressive here, because we'll look at browser support in a second. But hopefully we can see a quick example. Right, so the word hello at the bottom is bold and it's red because it's inherited font weight and color from the div and body rule sets. That is exactly how CSS works. We would expect that paragraph to be red, but as soon as we drop all initial in there, that paragraph drops back to being black and sort of a regular font weight. What all-initial has done is effectively prevented inheritance. It stopped things sort of cascading into that P selector. It does come with some quirks and oddities. Let's say we refactor our nav, and we've got the font size and font family set on nav primary, along with all-initial, and the nav primary link has all-initial and display line block. Because nav primary link has all-initial on it as well, it will no longer inherit the font size or the font family rules from the parent, right? The all-initial will actually prevent the inheritance in a very, very local scope. So we just need to rewrite our CSS and just apply these these declarations, onto the leaf node. It's a little oddity, a little quirk with how we're using all-initial or how all-initial works, but it's a very progressive way of defending against this kind of legacy stuff leaking in. Then we can just refactor this out once the project is finished. We can sort of remove all the all-initials and make sure everything's working nicely. It is very progressive. It's not really used much in production because of this. We have got some good browser support, but then we've got some absolutely dismal browser support as well. So we should never lean on all-initial as being a true fix for anything. The way I see it is kind of a last line of defense. What this means is that a large proportion of our users will not see any accidental regressions. It just buys us a little bit more time to fix things for the users on IE and Edge. But all-initial is a very progressive way of just stopping legacy styles leaking into brand new refactored CSS. Next little tip, something I did for a client earlier this year, an idea of a file that we called defense.css. Defense.css exists to solve a very, very specific problem. It answers the question, what happens when we need to run refactored code and legacy code side by side? That was a question asked of me by a company called Sky. I used to work for Sky like many moons ago, and I'm back consulting for them now on a new kind of UI toolkit build. They had a modernized design that they wanted to kind of update and needed to change the architecture of it. So yeah, I went in to help them actually build this new toolkit. But it had to be rolled out very gradually because Sky is an enormous company. It employs about 31,000 people. So yeah, it's not like a very fast-paced environment. We had to roll this out very slowly. We picked the homepage as the first candidate. Marketing loved that. We should go responsive. Let's try it on the homepage. But yeah, they picked the homepage as the first candidate, and we rolled it out there. But the problem was, we've now got a website that is using two completely different toolkits. One on the homepage, which is kind of refactored, and then an old one on other pages. So not only is that a performance nightmare, it also means that we have to run old and new code in tandem. We just have to run these two things side by side. I'm sure, as you can imagine, trying to get two completely different toolkits working nicely together on the same project doesn't really work too well. Everything just ends up looking messy. And you've got these two completely separate UI projects that just don't quite fit together. They don't have this kind of nice melded kind of existence. So what we decided to do was just create a third project called defense.css, which just contained all the kind of polyfill between old and new. Defense.css was run like an open source project. It was a completely new dependency. And the reason we had it as its separate dependency, well, there were a few reasons. Firstly, we wanted other teams to be able to use defense.css and contribute to it. When the help team were rebuilding their section of the site, we want them to just do npm install defense.css and install the new toolkit and have those breakages covered for them. We also want that team to put fixes back into the open source project for us to consume. So defense.css was run as a completely open source style thing, which just had all these fixes and polyfills between old and new. Another reason to have it as a completely separate project is that we can snip that dependency off as soon as we don't need it. We were building a brand new UI toolkit, and the last thing I wanted to do was fill a new toolkit with fixes for legacy code. I wanted to make sure it was very delete key friendly. We need to get rid of defense.css as soon as we can. And with it being delete key friendly, it meant it just contained the nastiest CSS I've ever written in my life. It was just kind of type until it looked right. I've worked with developers who do that as a job. That's weird. But no, it was just like type until it looks right, and that's what this file is full of. I was going to show you the kind of stuff that's in this file, but I've had to pixelate it because I worry it might violate the code of conduct. It really is that offensive. What you can see is plenty of importance down there. But this is absolutely horrendous, awful CSS, and that's completely fine. This is a temporary fix that is going to get deleted. It's like a polyfill between old and new. Once we've transitioned completely to the new UI toolkit, it's just a simple task to get rid of this dependency. So if you have to run a project where you're having old and new code in tandem, all of the fixes between those two versions should live somewhere where you can get rid of them. We do not want to fill brand new projects with fixes for legacy code. It just sets a bad precedent. The next tip is a real simple one, these RF classes. And this is basically as simple as any newly refactored work we introduce into the project, just prefix the classes with an RF hyphen. Immediately, this tells the next developer that this has been refactored. We can see that this is new work. A refactored class means that it's been taken care of. Anything without the RF, we know we need to still fix. That's good when you're reading code, but we can also kind of automatically do things like this. Any class that contains RF, put a green border around it. So we could have like a config switch in our SAS somewhere that says, show me what has been fixed, right? Or show me what hasn't been fixed. So for example, here we can see that we have refactored the nav and these content blocks. These are all fixed, but everything else needs to be done. So this version shows us the work that we have completed. It shows us the work that has been done. Conversely, we could write a selector like this, find me all of the classes that aren't classes containing RF hyphen, and put a red border around those. So we turn this config switch on, and we all of a sudden start seeing lots of red boxes on our page. Here we can see that the weather in London masthead has been refactored, but every single other thing on this page has a red box around it, has a red border. This is the work still left to do. Now, once we've done all this, and we've got a code base full of classes with RF hyphen in front of them, once we've finished the refactoring work, we just do a kind of find and replace. We automate just removing all the RF hyphen, and we drop back to just having nice kind of clean code. Obviously, we don't want to keep the RF stuff in there for like the rest of the project. So you need to kind of pick, you might end up using a different namespace that's more findable. So the actual RF, like the letters R and F themselves, are just implementation detail. What we do is we just have a task at the end of the refactoring project just to trim everything back out of there. Well, the next thing we want to look at is refactoring specificity. If you've ever done kind of a refactoring project, you might be taking a legacy code base that's full of nested selectors or IDs, all that kind of nasty old stuff. And we'll get collisions. Quite often you'll end up with collisions where legacy selectors have a much higher weight, and all these nice new sort of single class-based architecture stuff you're writing is just getting completely overridden, right? It's just ruining our new work. And again, similar to the defense.css, we don't really want to start filling our new work with fixes to guard against legacy, because it just means that we're setting off on the wrong foot. So let's look at some kind of funky, weird ways to start refactoring specificity or hacking it around. These are kind of like, look like party tricks. I guess don't come to one of my parties. But these are like odd little things we can do to just nudge the specificity of a selector around without actually changing what it's binding onto. Oh yeah, so dealing with dealing with specificity on legacy projects, it's really important to manage it safely. Like I say, we don't want to start loading our new style sheets with legacy fixes. We need to have some kind of fairly safe ways of handling it. We don't want to use importance. Important should not be used kind of in anger. We should always try and use important. There are places and times to use important. Sort of defensively to fix specificity problems is not the time for that. There are slightly less nuclear options that we have to nudge the specificity of our selectors around. If we take a look at this relatively straightforward bit of HTML, we've got 3 potential hooks in here. We've got the A element we could bind onto. We've got the class of foo. We also have the ID of bar. If we were to write some CSS like this, of course, the ID is going to win. Even though the ID is defined first, even though the element is defined last, the ID will win because of specificity, right? That's just how specificity works. So we've got 3 very differently weighted selectors here, all binding onto that same bit of HTML. And they're all working against their source order. That's one of the key problems with specificity and why it's so important to manage it well. Because specificity completely flies in the face of source order. It doesn't kind of adhere to the order of what you've written in your CSS. So it's like a second prong of how we could end up styling a document. Again, we could use important to kind of alter the precedence of these rules, but we should avoid that for as long as possible. Important is, like I mentioned earlier, a very, very quick fix with a very, very long tail of cost. So let's hack our specificity around. We can rewrite all of those selectors to have the exact same specificity as each other with no side effects or no kind of change to the HTML. Really keen to stress that these are hacks. Nothing in here is nice, nothing in here is advised. But it's just kind of to show that we can do this kind of stuff. The first one has an element and class equivalent of specificity. Rewriting an ID as an attribute selector gives it the same specificity as a class. Just simply dropping HTML in front of the .foo means that we can increase its specificity by an element, and then using the root pseudo selector, we can also target that same HTML element, but with a class level of specificity, because pseudo elements also carry, or pseudo selectors, also carry a class level of specificity. Like I said, everything on this slide is horrible and ugly and nasty. These are hacks, but it is a way that we could adjust the specificity of our selectors with minimal side effects. We don't have to refactor any of the HTML. We can just do this directly in the style sheet. And now all of a sudden, this link is going to be red because these have the same specificity. It is now source order that dictates the sort of the cascade or the level of application. Just to kind of extract this out into a more kind of digestible slide then, rewriting an ID as an attribute selector brings its specificity down to the same as one class. This doesn't mean we should start using IDs in our CSS. What this means is that if we have legacy sort of styles that is full of IDs, we can actually bring the specificity of them down to one class. If we chain two classes together, .foo, we can double its specificity without making any changes to the HTML. We can also put a third on there to treble its specificity. We could put 1,000,003 on there, and it will always keep working. Except, actually, funny bug in Firefox, 256 classes in a row will all of a sudden start overriding an ID. It's only Firefox that does that. And I tweeted this to Christian Heilmann. I'm sure we all know Christian. I tweeted this at Christian. I said, hey, look, there's a bug in Firefox where an infinite number of classes should be still less than an ID, but 256 tips over the edge. Are you aware of this bug, and is there a plan to fix it? And in typical Christian Heilmann fashion, he said, if you're having to chain 256 selectors, the fault is yours, not Firefox's. I was like, that's fair. And finally, the root pseudo selector is really useful for just bumping up any selector by one class worth of specificity without actually having to make any changes to your HTML. So we're not really doing any kind of location-dependent stuff. We're not chaining selectors together. We're not saying like a.button. The root pseudo selector is always there. It always exists in XML, SVG, HTML. Even if you don't write the HTML tag in your HTML file, it's implied. The browser puts it in there at runtime. So the root pseudo selector is a really easy way of bumping up any selector's specificity by one class without having to do any changes or without having to worry about any side effects. But again, these are hacks. These are definitely hacks. These are not a good idea. We should not be using these unless we absolutely have to. In an ideal world, we will go back and refactor everything into the point we don't need any of these hacks, but of course, none of us have ever worked in an ideal world. So realistically, one of these hacks will probably help us out of a situation at some point. Rewriting IDs as attribute selectors is really good if you're consuming someone else's HTML and you can't actually edit that HTML. I think the best example of this is one of the old Twitter embed widgets just had an ID on it, and that's the only way you could style this bit of HTML was via this ID. Which of course goes against everything we've been taught in the last sort of 5 years about CSS architecture. But just by rewriting the ID instead of hash Twitter, doing like brackets ID equals Twitter, we can target that HTML via a class level of specificity without having to refactor anything else. So it's a hack that is often useful. Again, just to point out, we should never use important in these kind of scenarios. Important does have a time and a place. This usually isn't it. Or never is it. Should stand by what I've written. Never is important. So yeah, these are hacks then. Getting on toward the end of the talk now. So these are definitely hacks. Where are we going to put these hacky, nasty bits of CSS? A couple of years ago, I was on a podcast with Chris Coyer, and we were just joking about an idea of, like, we need somewhere to just put all the nasty CSS. And I was like, why don't we just make a shame.css? Has anybody heard of shame.css? A few people. The idea of a shame.css is kind of like a semi-light-hearted way of dealing with all the nasty bits of code in your CSS project. So the idea of shame.css is you have a totally new style sheet reserved for just your hacky code. And it's code you had to write to maybe get a release out on time, but it's code that you're ashamed of nonetheless. Yeah, it doesn't have to be called shame.css, it could be called hacks.css, but the idea of shame.css is it's kind of lighthearted, and it just reminds you that every time you put a new line of CSS in there that, yeah, this is a shame that we had to do this. So it's just a dumping ground for all your nasty bits of CSS, all the bits of CSS that make you cringe. Another good thing about there are a few reasons why it's a good idea to have a separate file for your hacks, but I found as a developer that just apologizing for stuff instantly gets you off the hook. If you put it in a file that is called shame.css, everyone's like, no, don't worry, Harry, we get it. You didn't want to have to do that. So just sticking it in its own file just gets rid of loads of blame. Yeah, so the exercise here is isolating these hacks. Any hacky stuff we have to contribute, it's very important to isolate them. Hacks are inevitable. I'm a fairly pragmatic developer. I know that at some point I'm going to have to hack something and it isn't going to be very nice. It's dealing with those hacks that is the important bit. So it's important to isolate and signpost them. This makes everybody else aware that they exist. It doesn't hide all these hacky, nasty bits of CSS kind of throughout the project. It doesn't obscure anything. It keeps them in very plain sight, which then makes it easy to find and fix them later on, which we will ultimately be aiming to do. An example entry into a shame.css file then, it should look a little like this. We need that apology in there. We need that explanation so that people come along and understand that I did this for a reason. And this reason here is that we've got a slightly overzealous nested selector, which is overriding the styles of our button. So in order to get around it in the really kind of short term, what I've done is I've just chained the button selector, the button class with itself, just to override the specificity of the button A selector. Again, hacky, nasty, that's why it's in this file. But as long as you explain yourself, the next person who comes along and sees it understands that, okay, this exists for a reason. There's nothing worse than inheriting a project and being like, why on earth has he got like button chained twice, right? There's nothing worse than finding out and having no idea why. Simply leaving a small comment explains that, oh, cool, I only need to worry about this line of CSS in this context. So shame.css becomes a self-writing to-do list. All of your tech debt, all of your things you need to fix live in this file. It's very easy to find them. It keeps good code nice and visible, and it keeps good code nice and clean for a longer time. Has anybody heard of the broken windows theory? Yeah, a few of us. The broken windows theory is basically like a social psychology theory, I guess, which states that it comes out of New York, right? So New York City Council have got this policy of if there's a vacant government building, it doesn't matter if it's been vacant for 10 years and it's going to be vacant for 10 more years. If someone smashes a window at that building, they send someone out immediately to fix it. And the reason is because if someone else sees that there's a broken window, someone's going to pick up a rock and they're going to break another one. And it fights this kind of downward spiral effect of things just getting out of hand. It comes from this kind of social psychology kind of theory, but it applies to software projects as well. As soon as you see one important in a project, you think, well, someone else used an important, I'm going to use an important. So what we need to do is we need to keep all that nasty stuff out of view for as long as possible. What it does is it leaves 90% of our project, the place where we do most of our work, it keeps that nice and clean and keeps the bar really high. It encourages developers to maintain a consistent level of quality. It allows you to see which parts of the project are particularly problematic. I haven't had to use this much, but I did use it once to great effect. If you've got a dumping ground for all your nasty CSS, what that means is when a designer or a product owner or a project manager or a client comes to you and asks for something frankly ridiculous, and you say to them, yeah, this is not really going to be doable, it's going to be very hacky, can we rework the design? And they say, no, client signed off, you've got to do it. What you need to do is say, right, okay, I'm letting you know now that I think this will be problematic, but I'm going to go away and build it. Then, at the end of building that feature, you might find that it contributed 217 lines of CSS to your shame.css file. You've actually got some numbers there where you can say, our hacks in this project increased by 125% because of this feature. It's very rare you would have to use this, but it does allow you to put some rough numbers on problematic parts of a project. It also allows you to measure, even if it's not even if it's not a bad design decision or a weird client request, just anything at all in the project, this file will let you know what those things are. And the last one, I feel a bit Machiavellian, but it's easier to run git blame over one file than it is over an entire project. This isn't to trip people up. This isn't me being nasty and trying to find out who's doing bad work. I actually used this a couple of years ago on a project. I was the consultant, sort of front-end lead on this project. So I kind of architected and built phase one, and then had a handover project where I said, this is how this works, and blah, 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 and I'll be back in a couple of months to check how everything's going. And the developer was like, yep, got it, I understand everything. And I came back a couple of months later, and this file was full of hacks. It was just full of stuff. And it was all around the grid system. And what this taught me wasn't that this person was a bad developer. It taught me that I just hadn't explained our layout system very well. He was hacking stuff around that the grid system could already do out of the box. So it just allowed me to learn the fact that I hadn't explained something very well. So I was like, oh, cool, my fault, let's grab a coffee. This that you've put in here, actually, if you just use this class that's already in the project, it will do it for you. So it just allows you to keep an eye on which team members are struggling with which specific parts of the project, if they are at all. Right, beginning to wrap up now. I had a really interesting and quite enlightening point of view shared with me about 2 years ago. I was doing a workshop in London, and every workshop I do, I just ask everyone, who do you work for, what kind of stuff do you work on, blah, blah, blah. And one guy said, oh, actually, I was a civil engineer until about a month ago. Normally I build roads and bridges. And I asked him, well, okay, that's amazing. How are you finding web development? And he said he really enjoyed web development because he gets to refactor his architecture. He gets to tweak things as he learns more about it. And I was like, yeah, geez, because, you can't really refactor a bridge. You either get it right first time or you go to jail. Hundreds of people die, and you can't refactor that after it's killed everyone. I was like, wow, yeah, that's amazing. What a weird way of looking at things. As a developer, we get the chance to constantly refine things as we learn more about the system, how it gets used, how it scales, how it grows. That's actually really lucky. So this guy was like, yeah, in my industry, we don't get a chance to refactor things. Heart surgeons can't refactor a botched surgery. You can't really refactor a crashed flight. It's a real second chance. We are lucky. We've got a second chance that a lot of industries just don't get. And this it sounds really kind of, I don't know, like fluffy and kind of like a bit pretentious saying on stage, but it really struck a chord because I'd always viewed refactoring as a horrible job. I'd viewed refactoring as like a task that, I wish I didn't have to refactor this stuff. So no, amazing that we actually get the chance to do that. A lot of people just don't have that ability in their work. So anyway, just to start wrapping up then, remember, prevention is cheaper than the cure. If we can refactor things in a matter of hours to days, we should probably do it then, unless we can prove a reason not to. Technical debt is fine. Technical debt is very, very misunderstood. Technical debt is a strategic business decision. Technical debt is choosing to take a shortcut now to deliver something sooner with the understanding we have to pay it back later, and that's the key. We need to keep up repayments. Only refactor anything once we find tangible benefits, if we can prove that it's the right thing to do. If we can't prove that it's the right thing to do, we should probably leave it alone. Avoid long refactoring tunnels. Try and avoid refactoring anything with a large surface area. It will leave your project broken for longer. It will leave you kind of lost and uncertain. You might end up introducing more regressions than you actually, well, more regressions, basically. And finally, isolate and highlight everything. Isolate hacks, signpost them, highlight new work, highlight old work. There's no point refactoring something if the rest of your team don't know what has been fixed and what hasn't. So make every effort you can to signpost everything for them. And yeah, very last thing, I'd like to leave on a quote from Sir Robert Baden-Powell, founder of the Scouting movement. And he famously told his Boy Scouts, always leave the campground cleaner than you found it. I'd like to think that as developers, we have a shared responsibility to always leave the project a little bit cleaner than when we found it. Thank you very much for your time. It's warm here.
Wow, learned so much. I actually want to go back to work on Monday morning and start rewriting my
What a weird
CSS.
feeling that is. Like, I want to refactor something.
Yeah, so many tips and tricks in there. Now, we have a couple of minutes, so we can probably squeeze in a question or two if anyone has something that is really burning. Fantastic. Oh, hang on, Mike is coming to you. You're right in the middle, so you've made it a bit of a job there.
Is it a good idea to open several refactoring tunnels at one time, or should I do one thing and finish it first and then open the next one?
As an individual, one tunnel at a time. Your team could have several concurrent tunnels. That's completely fine. If you're going to have concurrent tunnels as a team, just make sure you're all refactoring onto the same architecture. Right? Like, get your linting in place. Make sure everyone's rebuilding in the exact same style. But as an individual, I would never recommend taking on 2 refactoring things at once, unless something is a blocker, right? So unless you might start trying to refactor the nav, and it might be like, well, actually, I can't refactor the nav any further until I've tidied this bit up. But as a general rule, refactor 1 tunnel at once. Does that help?
Thank you.
Cool.
Are you going to be around for the rest of the day so people can come find you with their questions?
I am, yes. Questions. I'm going to go and stop melting somewhere. But yeah, grab me breaks, questions and stuff if anyone's around for a beer later on. Yeah.
Fantastic. Thank
Cool.
you. So next up, we have...